All right, the cast rule. We touched upon the cast rule yesterday, C-A-S-T. When an angle ends up in this first quadrant, all the trig ratios are positive. When an angle ends up in the quadrant number 2, the only ones that are positive are sine and its reciprocal cosecant. If an angle ends up in the third quadrant, only tan and cotan are positive, the rest are negative. This is the third quadrant. And the fourth quadrant, the only one that's positive is cosine and secant. The other ones are negative. So basically the cast rule tells you what trig ratios are positive, when they're positive and when they're negative. And it all depends on where that angle ends up. If it ends up in the first quadrant, all the trig ratios of that angle in that first quadrant are positive, right? If the angle ends up here in quadrant number 2, only sine and its reciprocal are positive, etc. So the related acute angle of a given angle is the positive acute angle, right? An angle that's between 0 and 90. So this angle is between 0 and 90 degrees. It is the angle between the x-axis and the terminal side of the given angle. And I'll emphasize that when I draw it. A trigonometric function of an angle is essentially equal to the same function of its related acute angle. The sign of a trigonometric functions of related acute angle depends on which quadrant it lands in. That's the cast rule. The cast rule helps us remember the sign of each trig function. So when we're trying to find the trig ratio of any angle that ends up in this either the first, second, third, or fourth quadrant, it all depends on its related acute angle. So tell me, what is the related acute angle of 45 degrees? Can anyone tell me what the related acute angle is? You can draw it out. The related acute angle is always in between the terminal, the initial arm, which is on the x-axis, right? Or it's always between the x-axis and the terminal arm of the angle. So what's the related acute angle of 45 degrees? Huh? 45 degrees. Yeah, yes ma'am, you're right on. Okay. Let's look at 5 pi by 6. 3 pi by 6, 4 pi by 6, 5 pi by 6 ends up right there. If this is 5 pi by 6 and the related acute angle is in between the terminal arm and the x-axis, what is the related acute angle? But if a question is in radians, your answer has to be in pi over 6, right? Because that must be pi over 6 to make it a full pi, right? Radians. 225 degrees, what is the related acute angle? Well, if it, yeah, so, right. So 225 will end up there. 180 plus 45 is 225. So the related acute angle is between the x-axis and the terminal arm. So the related acute angle is 45 degrees. Can I explain anything better? Let's look at 5 pi by 3. Well, let's see. 3 pi by 3, 4 pi by 3, 5 pi by 3. Can anyone tell me what that related acute angle is? Pi over 3. How am I getting that pi over 3? You're basically asking, what do I have to add to 5 pi by 3 to get me to 2 pi radians, right? Do you see that bit there is pi over 3? Can I explain anything better? Any questions, anything at all? Okay. Cast rule development. Let's determine the trig ratios for 30, 150, 210, and 330. What do all of these angles have in common? Yes. They all have? Yeah. All have related acute angle equal to 30 degrees. Okay? So this is 30 degrees. This is 180 minus 30 degrees. 180 plus 30 degrees. 360 minus 30 degrees, right? They all have the same related acute angle. So that means all their trig ratios will have the same numerical value, but their sign will be different. So this is what I want to show you, okay? So let's draw, we'll start with 30 degrees. Well, you know from your special triangles, opposite the 30 is 1, opposite the 60 is root 3, opposite the 90 is 2, right? You need to memorize those special triangles we took the other day. So, sine of, we're going to do all the trig ratios for 30 degrees. And you know, I think you know, this is a review of grade 10 except for the reciprocal trig ratios, but sine of 30 opposite over hypotenuse, cos of 30 adjacent over hypotenuse, tan of 30 opposite over adjacent, cosecant of 30 is the reciprocal of sine, or hypotenuse over opposite, which is 2 over 1, which is just 2, right? Secant is the reciprocal of cos, which is hypotenuse over adjacent, 2 over root 3. And reciprocal of tan, which is adjacent over opposite, is root 3. So far, so good? Nothing new there, really. Now let's do 150 degrees. So 150 degrees, so I'm going to try to kind of reflect that over. This is 150 degrees. You know the related acute angle is 30 degrees. So opposite the 30 is 1, opposite the 90 is 2, opposite the 60 is negative root 3. Do you see how we're to the left here? So far, so good? Is there anything there that looks strange to you, or does it all look strange? So, what we're going to do is, we're going to do all the trig ratios. Sine 150, cos 150, tan 150, cosecant 150, secant 150, cotangent 150. Now, we are going to write it as a function of its related acute angle. Do you agree that sine of 150 equals sine of 180 minus 30, emphasizing the related acute angle? And that equals sine of 30 degrees. Now, the question is, Castrol, C-A-S-T. Can you tell me what is, if this angle will have a positive sign or a negative sign? Positive, right? Because in this, the Castrol tells you sine is positive, right? 1 over 2. Notice, same quantity, the sign, they're both positive. Let's look at cos 150. Well, that's the cos of 150 minus 30. That would be cos of 50 cos of 30 cos of 30 degrees. And, well, cos of 30 is root 3 over 2, but the sign is negative root 3 over 2. So we know that cos is negative in this quadrant. The only one that's positive is this guy. So this is minus cos of 30 minus root 3 over 2. Yes? It's equal to negative cos of 30, not cos of 30. Oh, this should be 180, right? Because 180 minus 30 is the 150. Do you see, even though this is 150 degrees, the trig ratio is dependent on the related acute angle, which is this angle in here. It's just a stepping stone to here to make sure to help you realize that the related acute angle is 30 degrees. I this usually you want to have the related acute angle in there. If you go 180 minus 150, right? You're just trying to show the related acute angle. It's 150 minus the related acute angle of 30. On a test, if you can jump from here to here, I'm happy. Well, because here cosine of 30 is negative. Because cosine of 150 is an angle that lands in this quadrant. See, it's negative root 3 over 2? Because it's in this quadrant. Yep.
If cos is negative, since the other side is also negative, wouldn't the negatives cancel out?
There's only one negative here.
They're negative.
Okay, be careful. We're equating it to this, but here we know it's negative, so it's negative cos of 30. Cos of 30 is a positive value, but cos of 150 is a negative value. We're not going minus cos minus, we're just showing it's negative here. There's only one negative here, not two. Yeah? Are we good? Okay. Okay, so this is cos of 180 minus 30. Sorry, it's tan. Is equal to tan of 30. But is tan positive or negative here? It's negative. So this is equal to negative 1 over root 3. This is cosecant of 180 minus 30. So is cosecant positive or negative here? Positive. So that equals 2. I can't fit these on without running into here. Well, maybe I'll write it here. This is secant 180 minus 30 equals secant of 30. But is it positive or negative here? It's negative, right? The only thing positive here is sine and its reciprocal. So negative secant of 30 is negative 2 over root 3. And the last one, well, if you can skip this step, you know it's some related acute angle of 30. We know when it hits this quadrant, it has to be negative, right? Because it's obviously negative root 3 over 1, so it's negative. And this is equal to minus root 3. Yes.
What is that middle stat really doing?
This one here?
Yeah.
You're just rewriting this. This is your stepping stone to get to here. If you don't need that step, that's fine. Because on a test question will be worded like this. Write secant 150 as a function of its related acute angle 1 mark and evaluate 1 mark. So if you can jump to there, that's fine. This is to help you identify what the related acute angle is, that's all. But if you know the related acute angle is 150, then of 150 is 30, then okay, let's now do 210. So this is going to be a -1 and this is going to be 2, right? Because the related theta RAA is 30 degrees. Now let's do it. This is going to be sine 210, cos 210, tan 210, cosecant 210, secant 210, cotan 210. Now, you know the related acute angle is 30, right? I don't want to make you write this all the time. So this is going to be sine 30, cos 30. The only difference is, the only thing we have to worry about is the sign. Tan 30, cosecant 30, secant 30, and cot 30, right? So the only thing is we just don't know the sign. Well, we know the only one that's positive in this quadrant is tan. We know that's positive. We know its reciprocal are positive. The rest are negative. Right? And you can verify it with this diagram. Sine of 210 is -1/2. Or you can just say -1/2. Cos is -√3/2. Tan is positive, 1/√3. Cosecant is -2. Secant is -2/√3. And cotan is in this quadrant, well, tan and its reciprocal are positive, so that's going to be it's going to be √3. Yes?
On the terminal arc, do we need to add an arrow?
Here?
Yeah.
No. You know, if you drew it like this, I don't really care. This is just a sketch. There's nothing here but a sketch, that's all. All I'm trying to show you is the relationships between trig ratios of any angle and its related acute angle, which is this. So this is going to be sine 330. You know the related acute angle is 30 degrees. Cos 330, tan 330, cosecant 330, secant 330, cotan 330. Well, you know the related acute angle is 30, so it's going to be, now we're writing it as a function of its related acute angle. Right? It's going to equal any one of these values up here, the corresponding values. Just here we know by the cast rule the only one that's positive is cosine. So cosine is positive, its reciprocal is positive, and the rest of them are negative. We know this from the cast rule. And you can use these numbers to verify it. This will be -1 and this will be 2. Notice sine of 330 is -1 over 2. It's negative sine of 30. Cos of 330 is positive, so that's root 3 over 2. This is going to be -1 over root 3. This is going to be cosecant -2. This is going to be positive 2 over root 3. And this is going to be negative root 3. Do you see the relationship? Right? All these trig ratios for all these different angles, they're all the same except for the sign. The cast rule tells you what to make positive and what to make negative. Right? I'm going to let you do that one on your own. Okay? You'll do the same thing for that one. How do we do this? Theta RAA is any positive angle between 0 and 90. Sure. So theta, the related acute angle is any positive angle, so it's any angle between 0 and 90, right? So we can draw any angle. There's my theta RAA, for example. Theta RAA could be 45, 75, 89. So you know this is Y, this is X, this is R.
Sarah Straczynski, what does it say after any?
Any angle, any positive angle, that's my short form for positive.
It's like a toe.
Oh, no, it's not any toe angle, it's any positive angle between 0 and 90. Well, you know, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Opposite over adjacent. Now we do the reciprocal. So now we're doing pi minus theta RAA. Well, you know they're related because their trig ratio, any angle, this angle, the related acute angle is the same as that, right? So you know this is going to be equal to the sine of theta RAA. We'll worry about whether it's positive or negative in a few seconds. And that's going to be cosecant theta RAA, secant. Okay, so you know by the cast rule that the only one that's positive, this is CA. Sine is the only, sine and its reciprocal is the only one that's positive, and you can verify that because well, this is going to be y, this is negative x, this is r, right? So you can see that this is a positive value, and r is always positive. So this will equal y over r. Now here, cos here is negative, so it'll be the negative of this, which is negative x over r. Tan here is negative, so it'll be negative, this should be negative, right? It'll be negative tan theta RAA, negative y over r. Sine is the only, sine and its reciprocal is the only one that's positive. So secant is negative r over x, and cotan is negative y over x, negative x over y, sorry. Since there's negative x over y. Yes,
For tan, you wrote y over r.
should be y over x, right? Thank you. Thank you for helping me on that. I appreciate that. So this should be negative, this should be negative, cosecant is positive, and this is negative, negative, and that one's positive. Do you see the kind of what's happening, the relationship with everything? Yeah.
Why is there a pi at the start?
Here?
Yeah.
Oh, instead of 180, I'm doing it in radians.
Oh, okay.
That's all. This is this is using radian. 180 is equal to pi.
So could it just be interchangeable? You could use 180 or pi?
Yeah, depending on the question. If the question is in degrees, you answer in degrees. If the question is in radians, then you answer in radians. Right?
What's the point of radians?
It is a better way of measuring angles. It has more applications in science and stuff. Okay, let's now do, let's just make it complete. This will be pi plus theta RAA. So this will be negative y, negative x, r. So, well, you know it's going to be equal to some function of its related acute angle, right? Now, we know here, the only one that's positive is tan, right? Because a negative divided by a negative is a positive. So tan and its reciprocal will be positive. The rest will be negative. So this will be negative y over r, negative x over r. This will be positive y over x, negative r over y, negative r over x, negative x over y. They're all related to these guys up here, right? You relate these to this. And the only difference is the sign of the ratio.
Is that for everything?
Should the last one not be negative?
You're right, positive. Because tan and its reciprocal are positive. Thank you for that.
Is it always the same?
What do you mean?
Like, are all four of them always the same as the first one, just the sign changes?
Yes. As long as they have the same related acute angle. Now for this one,
What's like the purpose of these ratios? Like to do what?
oh, you'll see in the next unit because we'll be graphing them. It's so you have an extension of angles that you can use trigonometry with. So this is going to be 360 minus, or 2 pi minus theta RAA. Do you think you can handle another section? Just do it? Okay. Sine,
No. Can we just have a nap time?
no naps. You can nap after,
Oh, yes, I wish we would. I found a study on how napping can increase
yeah.
happiness.
We should have reset time in the afternoon, not in the morning.
I know, it makes no sense to have reset after the first period.
When you're what? When you're alert.
Yeah, we've done nothing. We just woke up.
Okay, hang in there, guys. So you know it's going to be some sine of theta RAA. What's positive in this quadrant? Cosine, right? This one, and its reciprocal, this one. This is negative, negative, negative. Again, it's just the ratios are all the same. I hope I got those right. X. Can I explain anything better? Your job is to do this one in a few minutes. I just want to do a few more examples with you because I want to get you caught up to the other class. And if you don't like what you've written here, it's all written for you here and here. All of this is here and here. Yeah, but it's better if you write it out. Here. Go forward, you're going backward. It's all here, okay?
Nap time.
No, one more. Let's just do example 5. Now, yeah, on a test, the question will be worded like this. Write the following angles, while following trig ratios as a function of its related acute angle write the fall and evaluate. So we have to write all these guys as a function of its related acute angle and evaluate. So this is how you're going to use what I'm trying to present to you today, and I hope it'll become clearer. What is the related acute angle for 120? Good. Now you know 60 ends up here, so will this be positive or negative? Well, you know 120 ends up here. According to the cast rule, you know it ends up here. 120 ends up here, but sine is positive, and sine of 60 is root 3 over 2. See how easy that is? Right? Right? Oh, are you just humoring me?
Wait, is this from like those two triangles?
Yeah. Yeah, exactly. If you need to, draw your special triangles. So sine of 60 is root 3 over 2. You know because it ends up there, it's positive, so it's positive root 3 over 2.
No, fine.
Okay, let's look at this guy. What's the related acute angle? 60 cos of 60. All right, you know 240 is ending up here. Is cos positive or negative? The third quadrant, right? 240 is ending up here.
How's it 60? It's 30. It's on 60.
Well, draw. 240 goes here, right? This is equal to cos of 180 plus 60. Right? Yes? Right? If you were to draw this, 240, 180 plus 60, this is your related acute angle. It's the angle between the x-axis and the terminal arm. So the related acute angle is cos. You know it ends up here. Is cos positive or negative here? It's negative. So this equals negative. Cos of 60 is, well, it's 1/2, but because it's ending up here, it's negative 1/2.
That's
What's the related acute angle for 210?
Like,
30.
yeah.
30.
So this will be tan of 30. Oh, stop doing that, honestly. Who's flashing a light in people's eyes? Are you okay? Okay. Do you agree the related acute angle? Or if you need this step, then do it to find your related acute angle. You only do this to find your related acute angle. But if you don't need that step, then don't do it. So, you know, according to the cast rule, C-A-S-T, the only thing that's positive in this quadrant is tan, so it's positive. So what is the tan of 30 degrees? Well, look at your 60, 30. What's the tan of 30? Opposite over adjacent.
1 over 2.
Yeah.
Or not.
I'm going to write this, I'm going to just write this like this. Do you agree that this is equivalent to pi plus pi by 4? Agreed?
Yeah.
Because this is 4 pi by 4 plus 1 pi by 4 is 5 pi by 4. So you know the related acute angle is pi by 4. It's 4. Okay, so what we need the 45 degree triangle because pi by 4 is 45 degrees. 1, 1, right? So we are in 5 pi by 4 ends up here, C-A-S-T. We know tan is positive, so sine will be? And what's the sine of pi by 4 or 45 degrees? But because we're talking about an angle in this section, related acute angle for 2 pi by 3. What do we have to make up to come up to 180? So our related acute angle is pi by 3. So this is equal to the cos of pi by 3. And it's ending up here. Is cos positive or negative here? And that's going to be negative, what? That's the cos is 60, right? So it's negative. Pi by 3 is equivalent to 60. Yeah. So our ratio is?
How do you know which triangle to use?
Well, pi by 3 is a 60-degree triangle. Well, there's only two triangles. It's either 60, 30, or it's 45, 45. There's no 60-degree angle in there. So you have to go to this triangle. Okay, this is tan of what? Right, so I'll write 2 pi minus pi by 6. That's the related acute angle. So it's ending up in 11 pi by 6 is ending up here. Is tan positive or negative here? It's negative. So this is going to be negative what? You tell me. Pi by 6 is equivalent to 30 degrees. So opposite 1 over root 3. Because pi by 6 is equivalent to the 30, right?
Just take 180 divided by 6.
Yep. But this has to be in radians. You can't use degrees here. If it's a function of its related acute angle and the question is in radians, the answer has to be in radians. We'll call it a day. How's that?